Alright, so in this video I want to talk about how to take a sine or cosine function and determine what the amplitude is, determine what the midline is, determine what the wavelength is, and determine if there's a phase shift. The last thing is to determine if it's a sine or cosine function. So the first thing that we can do is we can figure out the midline. That's the one I like to start with, and the way you do that is you find out where there's a crest, which is at a value of 2. You find out where there's a trough, which is at a value of 0. Right? And the midline is exactly midway between those two y values, so in this case 1 is exactly between those two y values. So this function has a midline, y equals 1. Now the amplitude is the distance from the midline to the crest or the midline to the trough. So from the midline from 1 to 2, that's a value of 1. So the amplitude is 1. A way you can check that you put the midline in the right spot is to just check to make sure that going from the midline down to the trough is also a value of 1, which is the case. So I know that I did my amplitude correctly. Now the wavelength, that can be a little trickier sometimes. Especially in a problem like this, because if you trace one wave cycle for this curve, okay, you stop right here, and that's not on a value that is listed. This is not a value that I know. You could estimate it pretty closely probably, but we won't know for sure. What I like to do if that happens is I like to trace another wave cycle and see if I end up at a value that's labeled. I still haven't. But if I go a third one, after I complete exactly 3 wave cycles, I'm at a value of 360. So I think to myself, if I had 3 wave cycles, and that was an x value distance of 360, well then each one of those waves must be 120 degrees, and therefore the wavelength of one wave is 120 degrees. And you can see that this is approximately 120 degrees, so you know it's probably true. The next thing is there a phase shift? It depends how you look at the problem, but if you consider this a sine curve, which it is because it starts at the midline, that midline is right at the 0 mark where it crosses that midline. So as long as this is a sine curve, which it is, you can say that there is no phase shift. Now, to make that into an equation, right, you have to remember that sine and cosine functions are in the form of, of y equals a sine bx plus some phase shift called p, right, plus k, which is the midline. Right, so we don't have, in our equation, we don't have a phase shift, so we'll worry about A, B, and K. A is 1. You can write it in for A, but also if you leave it out, it's implied that it's 1. So you could write 1 times sine, because we said that it's a sine curve, of B. Well, if our B value is 3, right? Then we can put it right here in front of the x, 3x. We know B value is 3 because, let me just show you how to do that. So we know that the wavelength is equal to 360 divided by the B value. If we decided that our wavelength is 120, well, the number that gets you from 360 divided by 120 is the 3, which we already traced. So 3x, there is no phase shift, so you can close it. And then the plus k is where the midline is. Since the midline is at 1, you put a plus 1. You can simplify this down to say y equals sine of 3x plus 1. That's the same answer.